Let's all take a look at number 5 together here. This is a tricky type question. Why? Because it's asking you to take a look at just different rational functions and to identify A, H, and K, looks like. There's no B in there, so that's okay. But A, H, and K. So what you have to do is you have to change this into two parts. Into a part that has the kind of x in the denominator or whatever, and another part that's just a constant. Okay? So what we're going to have to do is we're going to have to try and split this rational function up into parts. Okay? And when you get into calculus 30, this is not in calculus 30, but it's in advanced calculus, where you will have to take a rational. Actually, that's what I'm doing with the advanced calculus students right now that have finished the AP. We're doing this. We're doing advanced integration, and this is like a baby step of what we're doing in class. Actually, I'm just going to do that lesson today. So we're splitting up a rational into partial fractions. That's kind of what we're doing here. All right. So how do we do that? Well, this does have a direct application to your future. So 11x plus 12 over x. So what we want to do is we want to rewrite that into 11x over x plus 12 over x. Because remember the rules for adding fractions. If you have a common denominator, you can simply combine the tops. So that's kind of what we have here. We have 11x over x and we have 12 over x. So this one's pretty easy, I would say, because these x's are going to cancel out, and you're going to have 12 over x plus 11. And here's the 12 over x plus 11. So you have that in that format right there. And so I think to confirm your answers, graphing technology, determine the location of any asymptotes or intercepts. Okay, well, from here we can say, well, I know what A is. What's A? 12. It doesn't ask for B, but what is B? 1. H is, x minus what? 0. Good. And K is 11. Okay. So remember, this is this. A times 1 over B x minus H plus K. That's what this is right here. So we can tell how our graph is stretching and is moving. So any asymptotes, okay? Asymptotes, do we have any asymptotes? Are there any restricted values in the denominator? Any factors in the denominator that involve x that are not divided out with simplification? It looks like this is what? There's our factor in the denominator, it's just x. So x equals 0 is a restricted value here. Does that make sense? So what kind of asymptote do we have if we have an x value that causes the denominator to be 0? Vertical or horizontal or what? Okay. Okay. So let's come back to it. Okay. Any intercepts. All right. So if we let x equals 0 to find a y-intercept. No, not 11. Sorry. 0 divided by 12 is 0. 12 divided by 0. Divided by 0. Divided by 0. Divided by 0. Okay, so this is undefined. So we have a problem there with x equals 0, right? And that's actually your hint. X cannot equal 0. So that's going to be, looks like a vertical asymptote of some sort. So there's your asymptote. Intercepts. Okay, do we have a y-intercept then? If we let y equals 0, can we solve for x?
Sure.
So as we were talking here, the definition of a y-intercept is the value of y when x equals 0. We already know that x can't equal 0. So we're kind of got a little bit of a hint that there can't be a y-intercept. If x can't equal 0, that means there's no y value for that x. But what if you didn't realize that? Could we just put a 0 in here and solve for x? Would that actually work?
Yeah. Yes.
Okay. So this would be negative 11x equals 12. X would be 12 over negative 11, looks like. I'm sorry. Yeah, I'm solving for x. So y equals 0, solve for x. So algebraically, looks like we get a value for x. So if you put this x in to the original equation, you should get 0. Is that what happens?
That's x-intercept.
Okay. Okay. So this is going to be what intercept here? Yeah. If y equals 0, that's going to be your x-intercept. Okay. So there's no y-intercept because when you let x equal 0, you got nothing. But the x-intercept when you let y equal 0, so this is the x-intercept. And there's no y-intercept. Is everybody okay with that? No y-intercept. But if you let y equal 0, you're going to solve for the x-intercept. Okay.
That's right. There's no y-intercept because since it's undefined, right?
Yes. No y-intercept because it's undefined. X equals 0 is undefined. Okay, what else do we... Okay, let's confirm this by graphing technology. So what you should be finding here when you graph this, so here's 12 over x plus 11. You see, it appears that we do have a vertical asymptote at x equals 0. So there's no y-intercept. The x-intercept, though, okay, negative 1.091. So does that match up with this? Yeah. Okay, so that's that point. All right. So let's do let's do C. Okay, you want to do C? Okay, let's do C. All right, so here's C. This one looks a little bit trickier because we can't just do this, can we? We can't go, hey, there's one and there's one. You can't split them up like that at all, right? You know you can't do that. So any ideas how we can split this up, or how we can factor this, or how we can rearrange this a little bit, or does anything pop out to you at first?
You add something. No, you add subtract something.
You add something and subtract something?
Yeah.
Okay. What's your thought?
Odd zero conjugate.
No.
What do you think?
So you add x plus 6 over x plus 6.
Okay, so you're suggesting we add x plus 6 over x plus 6.
And minus x plus 6.
And then, yeah, that's like adding 1. So you can't just add something to an equation unless you add it to both sides, or unless you subtract it. Okay, well, that's an interesting approach. So why did you do that?
So that, well, that's how I get it on A and B.
That's how you did it on A and B? Okay, but so where do you go from here then? Not saying you're wrong, I'm just wondering.
And you add up the first two.
Okay, so you kind of group these first two.
Yes.
Okay, so what do we get there?
4.
Okay, we get negative x plus x is 0, so we got rid of our x's there. That's kind of nice. And then we've got negative 2 plus 6 is 4. So this gives us 4 over x plus 6. Okay, and what is left over here? Minus x over 6, x plus 6 over x plus 6, which actually is? Minus 1.
That's smart.
Now this works if you can get rid of your x's here. It does provide for a constant, because this is a constant, and so that's a positive 1. This is a negative 1. So if you can get simplifying some things on top, then you might get into two terms where you can just eliminate something. So let's see if that works for B as well. Does it work for B? Did you try for B? Well, first of all, is there any other way that we could do this? And I'm looking in the book to see if they did an example any different way or not. So how did they do it in the book? Is this what they did in the book? Anybody find an example there?
No, not in our book.
So we've looked through the textbook, and again, for this course, this is, if you can't do it this way like we did for A, right? So if you have a situation like this, you want to do it like we did for A, split them up into the fractions and try and simplify. If you have something like this or something like this, right, you'll want to do this, add and subtract 1. You'll want to do it that way. So let's check to make sure this works for B as well. Okay? So B says what? What is B again? What is this, 5? So 5b, y equals x over x plus 8. Okay? So let's do this, everyone, and see if we can get this method here. So what we're going to do is we're going to add what? What am I adding? Or
X plus
subtracting
8.
or adding or...
X plus 8.
Okay, x plus 8 over x plus 8
Minus X plus 8.
minus x plus 8 over x plus 8. All right, so that is okay to do. We're adding 1 and then subtracting 1 back right away. Now, the issue is this. Are we okay with adding this, or do we want to subtract this? Because remember, we kind of want to get a constant on top, right? So if we go back to the question, look at this, a. See, we want a constant on top. So that's kind of your focus. You want to get rid of this x. So which ones should I combine? I'm going to combine this with what? Yes, the minus 1. Okay? Because really this is subtracting x and subtracting 8. So guys, yeah, this is important. Watch this. So this is going to be y equals, we're going to do x over x plus 8 minus x plus 8 over x plus 8. And this is going to be a plus 1. When we simplify this, we simply gather our like terms up top, and that's going to be x minus x is going to be 0, and then minus 8. So it's going to be negative 8 over x plus 8 plus 1. There you go. So we want to get rid of our x's on top, so we can pick and choose which one we want to subtract or add. Okay? So that's question number 5. It's a bit tricky there, but now we've done that together.